Uh, my name is Pedro Fuentes, and I take care at SEALSQ of what we call the Trust Services Business Unit. And I'm here to talk mostly about that concept, about the concept of trust. We just saw in Daniel's demo that there were some exchanges of keys. So Alice was sending some keys to Bob and vice versa. So the point here is how does Bob really trust that the key that he's getting is from Alice? And trust is the key word here. So if I give you my business card, it's not mine, but it's a random business card. Can you really trust that this is me? Can you really trust that this is my name? Can you really trust that these are my identity attributes? So first of all, there's no standard here, no? We can have different identity attributes. Some of these will have my email, others will have my mobile phone number. But the most important thing is that maybe I went to the print shop in the corner and I printed myself, okay? So you cannot trust that. I think that we agree on that. If I give you my ID card, that things will change, right? First of all, we have the standard. We know which identity attributes we will find here. We have some security mechanisms. So we have some microprinting, we have a chip, we have different things that I can check, okay? But the most important thing is that I trust the issuer of this card. So I trust the government that issued this card, and that is telling me that I can trust this as an identity of a person that is presenting it to me. So in the digital world, we have exactly the same concept, right? So we have the concept of what we call the root of trust, which is the source of identities that we can trust on. In the particular case of IoT, we will talk about two kinds of root of trust. We will talk about the software, what we call kind of virtual or software root of trust, and the hardware root of trust. So the software root of trust, let's call it as the issuer of an identity. So if we are talking about the public key infrastructures, certification authority that is issuing a digital identity, which is basically the public key of Bob linked to the identity attributes of Bob with a digital signature from the certification authority. So this is a standard format with predictable identity attributes that is coming from a trusted source. So it's matching the same characteristics of my identity card, right? So this digital identity, I can trust it because it's coming from a trusted source. On the other hand, in the IoT world, we also talk about the hardware root of trust. We can trust on certain cryptographic operations because the keys are protected in a secure environment like a cryptographic chip. If we combine both, is when we get to the ideal situation, right? We have a trusted digital identity with keys protected in a secure chip. And this is something that really makes us a bit unique on this. Because as far as I know, we are the only company that is at the same time a publicly trusted root of trust, because this is what is WiseKey SEALSQ, and also a secure microcontroller maker that can combine both. We are talking today about post-quantum cryptography. That means that we need to adapt this technology, public key infrastructures, and we need to create a new root of trusts that will be using these new algorithms that we have been seeing today. So we need to, as we saw today, and I will not repeat because there's been a lot of speeches about that, but we saw today that we need to adapt PKI to quantum computing. In particular, as Bernard said, for example, we all agree that quantum computers are not supercomputers that can do anything faster. Quantum computers will be especially good in certain things, and especially in number crunching, so number factorization, which are the techniques required to really break this algorithm. So we need new algorithms that are using different techniques that are not affected by this new technology. Also, so we need to plan this transition. We have been seeing today different concepts about crypto agility and hybrid certificates. We need to get ready to adapt our systems, not necessarily to adapt today to quantum technologies, but we need to start a process. And that process maybe starts by establishing mechanisms that allow us to change cryptography in an agile way. So we are talking about crypto agility. So we can quickly replace keys. We can quickly extend the length of the keys. We can quickly adapt to new algorithms. So crypto agility is about that. And we can start today by establishing the mechanisms to manage properly our existing keys with the existing technology, but at the same time establishing the foundation to adapt tomorrow to new algorithms. Okay? So proper key management is a must. Also, we saw today there was mentioning about harvest now, decrypt tomorrow. This is something that we need to be conscious. So we need to analyze our cryptographic assets. We need to analyze for how long our key information needs to be protected and act first on this kind of information. That was also mentioned today. So in summary, we need to start today to adapt our systems for what is coming tomorrow. We saw that today also, so I will not repeat that. There were some questions today about the readiness of existing software for the new algorithms. For example, today, what you can do already is to use key exchange mechanisms like what it was known as Kyber, MLA KIM. It's already supported in Google Chrome, for example. You can establish secure connections using post-quantum algorithms today, not for digital signatures, but for the key exchange mechanisms. So there are tools that are starting to be available today, and there are adaptations that are being prepared. SealSQ or WiseKey is present in all the standardization bodies. For example, there are already discussions to adapt to post-quantum secure email standards. There are starting to discuss about using this in public TLS. For now, the trend is about reducing the lifetime of certificates, but definitely adopting post-quantum in TLS is also coming. And there are we're talking about the protection of IoT devices. There are already discussions in standards like Matter, for example, for home automation, where the new needs to adopt post-quantum algorithms are being defined. So we are not fully ready to use post-quantum algorithms in standard software, but this is coming, and what is very important is to be ready to establish proof of concepts, to establish tests in the companies to be comfortable with all these new algorithms and the new techniques. In SealSQ, we are specialized in what we call managed PKI services. So we deliver different services that help our customers to manage their keys and digital identities for objects without getting into all the complexity of managing an in-house PKI. This is the platform that we call Ines. I can do a very quick demo. And please bear with me, because apparently I'm clever enough to build a PKI system, but not clever enough to manage a friend QR. Okay, the URL is still there. I don't need to type it. Okay. First time. Okay, impressive. Okay, so this is our managed PKI platform for IoT, what we call INES, Internet of Things Embedded Security. This platform is publicly available. You have here the URL. You can go here. You can create a trial account. You can obtain post-quantum digital certificates for free. It's available for everyone. You have even here all the documentation. So you have here the user manuals. You have that this is proposing an API. We leave that open, available for everyone, so you feel free to try it. And I will just do a quick demo on how to create a post-quantum digital certificate out of our post-quantum root of trust. So I will not get into the details, but basically it's as easy as coming here, create a certificate. This is a multi-tenant platform, so I will select the user. I will select the type of certificate I want. I will choose the new standards, FIPS 204. We support even the old ones because there are some legacy or previous tests that are still using it. This is what it was called before Dilithium 3, which is MLDSA 65. I could upload the public key or the certificate request. I will make it easy, and I will generate it in the server. So I put the identity attributes for this digital certificate. And let's say, again, sorry. Nope. Yeah, sorry. Okay. You make things really complicated. Okay. Okay. No, I will manage. Eventually, I will do it. Bear with me. Okay. Okay. And okay. So it's as easy as providing the identity attributes, and in just 1 second, I get my post-quantum compliant digital certificate using ML DSA 65. If I wanted to use it for any practical purpose, there are tools that I can get. For example, I recommend you to check about a project which is called Open Quantum Safe. This is a TLS library which is compliant with all these algorithms. And also, if you look, in the internet for SEALSQ Quantum Lab, and I guess that you will type it faster than me. Okay. Okay, you will find, what is it? Sorry. Okay, so in our website, you will find online resources that will help you to not only to learn about the process, but also some practical examples. So we have here some what we call recipes that teach you how to create, how to install, for example, this crypto library, Open Quantum Safe, how to use it to generate keys, how to use these keys to get a digital certificate from Ines. So please take a look to this Quantum Lab and also to our Ines platform, and hopefully it will be useful for you. So that's it. I didn't want to make it